Hi everyone, welcome to the MathSpellBook live stream. I'm your host Peter, and basically we're going to get back into doing a little physics as well as hopefully get back to the math proof that we were struggling with yesterday. Hey non-wizard, how's it going? Marking your territory, huh? It's okay, I'm not a good speller either. That happens, and I'm an English major, so like, it's embarrassing that I still can't spell that much. So first, let me see my problem sheet here. So we also have to do 46. So let's just copy that. And we'll paste that right here. This here, expand it. Okay, so we gotta do these 3 problems. I did do the problem I did this morning was like 39, but that was like a pretty easy one. It's just basically doing the dot product of 2 vectors with different values, so that one was pretty simple to do. Now let's get into doing this. Okay, so 43. Given 2 non-zero vectors a and b, show that if, I'm guessing the magnitude of a plus b is equal to a minus b, the magnitude of a minus b, then a is perpendicular to b, given the vector, okay, so b is this totally different thing. Given a is equal to 4i minus 3j, Find a vector in the xy plane that is perpendicular to A and has a magnitude of 10. Is this the only vector that satisfies the specific requirements? Explain. I think the answer to that question is no. But you know, like I have to remember certain things that I've learned. So maybe I'm wrong. Because you guys have seen me get these things wrong on the live stream a couple times, probably all the time. So 43. So A. Okay, 2 non-zero vectors. So we'll put AX plus AY, and then we'll have B, so BY. Hey Sascha, how are things going for everyone in chat? I wanted to make I wasn't sure if I asked you like what's up with you, non-wizard. Okay, so this feels like more like a proof type question. I think these type of questions I end up skipping when I was like doing physics as a class, because I was like, oh my gosh, they're going into the proof abstraction with math a little bit. Let's just do it step by step, so that way we doing good? Cool, cool. Yeah, like for the sheet that you, the second sheet, Sascha, I actually have to like remember everything you taught me about that portion. I have to like re-look up relations again. Okay, so A plus B vector I. Oops. It's okay, take your time. No problem. And yeah, this one feels like more like a math proof question than a physics question. So oops. I mean, would it be minus or plus? Now it's basically like those moments where you're like, I think I know, but at the same time it's like you don't know as much as you think you know. It's A minus B. I mean, usually I would put a plus because the operation is being applied to the components. Okay, so now we have to prove that if, you know what? It didn't say in the question we have to do it as a... It didn't say we had to do it in XY coordinates, right? Because then I'm thinking, like, how can they be equal to each other? And I'm thinking that this is not going to do it if we take the magnitude of these. Can we do these with, I'm thinking about doing it in polar coordinates. But maybe that's just thinking too... Because we want these two to be equal. But the only way they could be equal is... hopefully they even out. Now I can see why it's 2 dots, because you actually have to think about... like, usually the dots indicate difficulty. So... should I leave it in Cartesian coordinates, or should I try it with polar coordinates? Or maybe I should rewrite this. So, thinking about it a while. Maybe instead of that, we'll do it like this. Oh, yeah, I was supposed to write A. Oopsies. Rewriting a lot of stuff is always gonna make your brain run in a different time zone. Now the question is... Are A and B arbitrary? Yes, I do believe so, because it basically says given two non-zero vectors A and B, show that if vector A plus vector B is equal to, well, the magnitude of the sum of the two vectors is equal to the magnitude of the difference between the two vectors, then they're parallel. I mean, not parallel, they're perpendicular. So I think they are supposed to be arbitrary. may have a point there. A squared cosine square of theta 1 plus 8 times b maybe we can line up some terms here, or at least like have some terms work with each other. So unfortunately, these cosines and sines are not the same theta, so we can't use the same like addition trick. Would have been nice. Would have been nice, right? So now we're like in this situation. So the question is, what can we do about it? Because I don't think there's a trig identity that relates to this type of scenario. Well, since we have a little bit of a long job on this side, let's see if we can probably just start doing on the other end, which is like a minus b. So I think we'll probably do it on this side. See how it goes. Yeah, it's basically the minus sign that differentiates the two. Because this one is plus AB, this one's minus AB. Yeah, according to the problem, it basically says given two non-zero vectors A and B, show that if A and B, the magnitude of A plus B is equal to the magnitude of a minus b, then a and b, vectors a and b are perpendicular. Orthogonal, I'm guessing. So they're only different by a sign. That's the only thing. The thing of it is that how do we prove this? Unless we just assume that theta is particular. I mean, if we said theta 1 and theta 2 is pi, then oh no, that won't work though, because then this would be -1 and this would be -1. This would be -1 and this would then that would be plus. Yeah, but this one's like still gonna be minus. Yeah, I'm getting close. It's just that we have like two different I don't know if there's a trig identity that involves these, like two different. Now I feel like I got a brainstorm, like I had like an epiphany moment, because I feel like there is a trig identity like this. Trig identities is the thing that I have not fully I don't really recall them that much unless I have to look them up. But then I remember the trig identity was like, I think it was this, but then it's a minus sign in there. I think. Is it laws of is it cosine? Or... I think it's like the double. Is it the double angle one? By the way, you may prefer to work with the square and get rid of the square roots. Yeah, I probably should have done that first. I probably should have done that first, right? That would have been much easier, because then I would be like, oh, I don't have to worry about the square root here. But I already dug my grave into it. Which trig identity was it? I don't want to look it up. Come on, brain. I know you have it in you. We gotten this far to thinking of it as a trig identity, but what is it? I think I know it involves cosine. Because I know with sine, it's basically cosine, sine, plus cosine and sine. But I forgot exactly what it was. Was it, shoot. I think it's like cosine, and then I think like it's supposed to be theta minus something. Because I know with cosine, the signs are switched. The double angle formula follows from it, but it's known as the addition. Yeah, I was thinking it was something like that. Yeah. Hey FizzBuzz, how's it going? And if you guys are not familiar with FizzBuzz, I will give you a shout out. He streams math content as well as like other like mainly like programming a little bit and all that stuff. So if you guys are like into like programming and like math, as well as I think you also do physics on your channel, right, FizzBuzz? So I think it's in your name. doing well. Going and not prepping. It's fine. It's okay. You don't need a trick identity question for you to have used the hypothesis, or everything you did would work for any vector and vectors A and B. Because it says show if A and A plus B and then that's the first part, and the second part seems like it's just a question that throws us like and vector A here, because we have like A and B here. Yeah, but in your argument, you have to use the hypothesis so far. I feel like I have to, because it seems like the question is asking us to prove something. Because it seems like B is not related to the question up here. Because it's like we have A and B here. Because the question says show that the sum of the vectors, the magnitude of the sum of the vectors is equal to the difference between the vectors, or the magnitude of the difference. So I feel like we have to show it, like doing this like tedious method. Let's see. Double angle trig identity. This is not the one I'm thinking of. Here it is. So sine is when it's like, yeah, I remember that sine is the one that basically is like switched up. So this one I think has to be cosine. So cosine, I think it's supposed to be the cosine. Show the one with sine, but where's the one with cosine? Oh, here it is. So cosine in this case. No, this. I mean, I think like at this point we're gonna have to assume that theta is practically like the thetas, they have to equal something in order to show that they're equivalent. So in this case, if it was like 90, then that means it would be 0. Oh, maybe that's what we needed to do. Like, so 90 minus 90. So basically we would have to suppose that theta is like equal to like 90 degrees, because we got like all these together, and thus that would lead us to, so if we showed that if they are perpendicular, then that means the angle between them is like 90. So 90 degrees, so then we would be left with, because it doesn't matter what like it is, and then we would be left with this. I mean, that's the only way to basically because they're supposed to be perpendicular, so if they're perpendicular, then basically that would like even out, because then it'll be 90 minus 90, and that would equal 0. Oh, no. You would have to assume that that doesn't work either. But we have to assume like one of them is just erase this. I mean, we're getting pretty close, because we just want to get this so that the magnitudes are the same. The thing of it is that we have to basically get the thetas to cancel out. Or no, not cancel out, but basically equal 90 in this case, because we want them to be 90 degrees. I mean, this sign doesn't matter, so we can probably leave it in. Because if they're perpendicular to each other, then that means that they both have to be 90. But if this is 0, then that means this becomes 1 instead of 0. We want it to be equivalent to 0. Then again, if they are perpendicular, no, what am I thinking? Shoot. Cosine plus theta 2. Dang, that would be like 180 degrees. Yeah, because that would be 90 plus 90, and then... Yeah, and we can't have it 0 either. Yeah, that'll be 180, and that'll be minus AB, which is not what we want. We had this plus. I mean, if we had it equal to 45 degrees, I mean, we can do a little trick though. Oh no, that wouldn't work, because then this has to be -2. Because I was thinking that we would change it to 45 degrees for both angles. Because then we can add 45 plus 45 and that will give us 90 degrees and then get rid of this term. We did like the trick correctly. I mean, we could basically turn this, because if we don't take away the minus sign, then this will be like plus one, and then we could do with this trick here. The problem is that 45 minus 45, because then this would be still remaining. It's just this little part that's like bothersome here. Because I was thinking like if they're perpendicular to each other, then that means this would be 90 and this would be 90. Unless we're doing the perspective of the angles of the from the perspective of the vectors themselves. I guess I'm gonna have to go on Quizlet and see what I'm missing here. Chapter 16, chapter 6. I think it's problem number 43. Step 2, recall the approach of the scalar. Oh, I forgot about this thing. Wow, I made it so complicated for myself. I forgot about this this relationship. But then again, the section did say it was for dot product, so that's my fault for not following the like using dot product to help me out in that case. Yeah, that was basically the solution I wanted to you after you solved it. That's my fault for not, like, actually thinking of that earlier. Let me just zoom out. Yeah, I forgot that this part was actually, like, involving the dot product. I was thinking of the actual, what is it? The actual definition of the magnitudes. Oh well. Let's see. Show that. I mean, we did do, like, I guess the factoring correctly. The only thing is that like, I think from this question, I'm, like, wondering, like, how do you actually pull the dot product from this? I mean, with the dot product, you know that when it's, like, when it's, like, equal to 0, that's when, like, it's perpendicular. Like, I understand, like, basically that part. The one thing is that how do you get the dot product from this relationship here? Oops. Didn't mean to mark it up like that. That's fine. I won't erase it, because if I erase it, I'll get rid of this too. Let's look at the question and see. It's a non-zero vector. Proof this. To find the scalar product in right, it's 90 degrees. Square equivalence of times 2. Is 4. I get what they're saying here, but the thing of it is that I'm still having a hard time, like, thinking about, like, I'm still not seeing the connection between this relationship, to, like, the relationship they're drawing up here. Because, I mean, like, the one thing that I'm confused about is because it seems like they're just writing this separately from this, but at the same time, I'm trying to find the connection that connects these two. And I'm, like, looking at the way that they wrote the answer, and it seems like it's kind of like they're jumping from it. Because it seems like they just present you, this is, like, the actual question, but then when I see this, I'm like, okay, yeah, I see that this makes sense. But the one thing is that it seems like they came from this to jumping to here. And I'm like, okay, like, it's supposed to be 0, right? I understand that. The one thing is that suddenly they go back into the dot product again. And I'm like, what is the unifying factor between these two? That's the one thing that I'm trying to figure out. Because it seems like they just jump from dot product to this and then dot product again, and I'm like, what is the thing that connects the two? Yeah, that was basic. Oh yeah, I already read that. The solution works in any dimensions, even infinite. Dot A. That usually is the definition of the norm. Oh yeah, step 3 and step 4 are kind of unrelated. Step 4 is important, is an important one. Yeah, like I understand where this comes from, because when you look at the question itself, let me just move this here. When you look at the question itself, mainly, it just gives you this to work with. And I think, like, for me, I have to, like, think about, like, okay, you give me this question, how am I going to lead that to where you want the solution to end up, right? So I'm still trying to find the connection between the dot product and, like, this here. Because we know that we have to use the dot product. The thing of it is that what is the thing that I have to think about in order to lead me to here? And how is this supposed to lead me back to this? That is the one thing that I find very perplexing about this. Because usually whenever I struggle with a question, it's usually this type of relation. Because sometimes, like, yeah, like sometimes when you think deeply, it's like, oh, there's a hidden definition here, or there's a different way of thinking about it. And I think for me, it's like finding the connection of where this lies, this relationship, is the thing that's kind of bugging me. Because I'm like, what am I missing here? Do you get step 4? Let me see here. Step 4. This one I understand, because it's like, yeah, we want to get rid of the square root, so that's why you have it this way. So yeah, it will only be 0 if, like, we have 4 times the vector A with the dot product of B. And then with the dot product itself, basically, we end up with cosine with the magnitudes. Oh, here we go. Maybe that's what I'm missing. Okay, yeah, so then basically it's minus the A's, minus the B's, and then we end up with here. And then basically we probably end up with cosine equaling 90. Thus was, okay. Maybe that's what I was missing. Okay. Yeah, I think that's what I was missing, actually, because the dot product is signified by this relationship here. And if it's 0, then basically it's going to end up here. So it doesn't matter in that point. Okay, now I think I see what I missed. Yeah, because I think, like, right here, that was when I was missing something. Because I was like, okay, here's the relationship we're looking for. So basically what they want you to do is that, obviously they set it up like this. Raise this up here. Yeah, I think that's the connection I was looking for. Because, like, I didn't see this part. And I was like, oh, okay, so that makes sense. Because these two cancel out, and these two cancel out. And then we're left with that. Okay, that makes sense. Let's see, given the vector... I don't know if that would be considered a math proof type question. Because I sometimes wonder, like, I think, like, those type of questions are meant for people that are trying to get into theoretical physics. Because it seems like more like a math manipulation question. I don't hate it, it's just that, like, I admit I do feel defeated because I didn't find the relationship quick enough. But then again, that's what you get used to when you do, like, math and physics. You have to get used to the feeling that you don't know everything. But of course, like, I don't want to waste time just thinking about it too much. Because that's my problem too, is that, like, whenever I get stuck on a problem, I feel like I have to think about it, and if I don't come to the epiphany or the eureka moment, like, it just takes up too much time. But at the same time, I don't want to look at the solution willy-nilly, and I'm like, oh, okay, so the solution is like this. Perpendicular... I mean, the magnitude of A... just gonna be 4 plus 3. That's 16 plus 9. Leave us with 25, which is 5. So, I mean, now we basically have to find, given the vector perpendicular to A that has the magnitude of 10, is this the only vector? I don't think it would be the only vector if it's asking that type of question. The other steps are just about what means for A and B to be perpendicular, and what is the angle. If you take the definition of A and B are perpendicular, if the step 4 is all you need. Yeah, I had to really look at step 4 for really deeply to actually see what I missed. But you guys get to see my deep struggle. Actually, I feel like most of the streams is just me struggling. Like, basically, I feel like... But then again, I'm also learning more, but at the same time, it's like, I feel like you guys see me getting defeated more and looking at the answers than me actually solving the problem myself most of the time. I don't know, maybe I'm doing something right to show you guys that. Whether you're watching this on YouTube or whether you're watching this on Twitch. Because I always appreciate it when you guys give me a pep talk in the chat. Because I mean, technically, if you were to have a vector B in this case, so let's see. Find a vector in the xy plane that is perpendicular to A that has a magnitude of 10. So it has to have a magnitude of 10 and it has to be perpendicular to A. So we're going to have to use the dot product here, like the cosine version of it. So magnitude of A times the magnitude of B cosine, and we know that they're perpendicular, so it's like 90 degrees. So B's magnitude has to be 10. Now the thing is that because b has to be like, its magnitude has to be like bx plus by, that would mean we have to get like numbers that basically will allow us to get 100, because that's the only way we can get 10 in this case. I mean, I feel like there are other ways. Usually A is the definition of the angle between the two vectors. Not quite. You need an orientation to define theta. That's also true, yeah. I think it's because like it says it's perpendicular, that's why I assumed that we would use the cosine definition. But then again, you can also know that it's perpendicular because it's equal to 0. That's also a better approach. That could also be a thing that I'm not thinking about. I meant to click the eraser button. Yeah, that's the thing about like whenever I think about these things, is because I always think like it feels as if like whenever I think of a solution, it's like it feels as if it's like, I guess, like the secondary approach. Well, like someone that knows more than me, they would probably think of like the first approach that that I didn't consider, and I'm like, dang. But then again, I think that's how, like, you know that when you try to get better at the subject, there's always going to be people that know more than you. And I end up wondering, is like, do I think of the right approach, or do I think of the second rate approach? And sometimes I always think of the second rate approach, and I'm like, dang, like maybe I have to like actually like find a way to actually know the subject in a way that's like deeper. I don't know. I guess this is what students deal with all the time. It's like they basically think that they basically try to think of an approach and it doesn't work, and then they have to basically try to consult everybody that's like within their inner circle to basically like, oh, I've tried this problem over and over again, but I can't get it right. And then like they talk to someone who knows more than them, and they're like, oh wait, you could have done this. And then they're like, oh my god, that's like right in front of me, why didn't I think of it? But I think that's how it is with like all students. Whether they self-teach themselves or whether they're going to school or both. Are you able to find a vector perpendicular to A without caring about the norm? Well, people already saw the trick. Like, what do you mean by that, Sascha? Like, which trick are we talking about here? Because you know that we have A and we have like 4 and plus 3, then 3 y. supposed to be 0. Problem is that we can't just do like substitution. It would have been nice. I mean, like using a linear equations to basically figure it. What is it? System of equations to do it. But unfortunately, the magnitude is not equal to that. Like it's not equal to like bx plus by. It has to be like the square root. When you say people found a clever solution and you found the second solution, because yeah, the way that question sounded, I don't know why it made me think of linear algebra. That's why I was thinking it. Because it says, but the thing is that it says the magnitude is the magnitude of 10, and I'm like, usually when I think of the magnitude, I think of the norm, which is like this. Like you take the square root of like square the numbers and all that stuff. All of this is linear algebra, practically. Let's get rid of bx. So multiply by -4. -4. And then this would be -40. 0 plus 4b. And then right here, that would be negative by. -1. So by is equal to 40. And if that's the case, then basically, so then bx would have to be -10. But if you find a perpendicular vector, you can just divide by a constant that gets the norm right. Well, this is what we end up with. Now the second question is it the only vector that specifies the requirement? And given that they're both even numbers, for some reason I mean, being even numbered probably doesn't mean anything, but it kind of feels like they could be like scalars. So you could probably reduce this all the way down to its like major components. Like if you do it from like, if you keep reducing by 2, you would be left with like 5 times 5 on bx, and for by it would probably be like, if you reduce by 2, it would be like 20. So then it would be like 5 times so if we reduce it to its lowest components, oh crud. So let's imagine if it was like minus by plus 20j, and let's just say that's a hypothetical b here, so let's just play with it a bit. So if we do that, we're left with this plus -3. Yeah, that's not gonna, I don't think that's gonna work, because then we'll be left with -20 here, but then we'll be left with -60 here. Yeah, that doesn't work. Oh yeah, it's negative. Oops. This is why arithmetic is not my best subject. Because I always miss these small details here. So that means... Okay, yeah, that's wrong. Okay, so it should be -7 then. Yeah, because then there's... Well, that is pretty... interesting. Very interesting. That would mean that... Actually, I probably should have, to make it easier, I should have done it a different way. So, instead of 4 now, because we changed that, might as well just multiply everything by 3. Because then this goes away. Vector that can satisfy the specific requirements. I mean, probably because it seems like no, maybe not. Huh. I guess you want the second equation to be condition of the You mean this equation? Is that what you were talking about? Yeah, the only reason I wrote that is because you told me to write that equation. Because I remember you said write the equation. Unless you didn't mean that one. That's the reason why I didn't write this in the beginning. Because I knew the norm was like this. So I'm like, how is the magnitude supposed to equal, like, you know, this? Because there was a part of me that was tempted to write this because, like, you know, it looks like a system of linear equations. I just thought it was funny. But then when you said write it, I was like, oh, okay, maybe there is a rule I can do this. That's the reason why I wrote it. I mean, I think there's plenty of ways to make this 0, but also have the magnitude of 10, I think. Unless that's, like, supposed to be a unique thing. Because the thing is that the magnitude of b has to be equal to 10. And the thing is that we can, like, I can only think of, like, doing this. And the only way I think to get 10 is basically just to get 100. So if you had... Yeah, we just need to find a non-zero solution. Yeah. Because, I mean, there's a lot of numbers, but the thing of it is that what number... I mean, do we have to find a number? I don't think we have to find a number. We just have to find, like a vector that we can use. Because I'm guessing it's not going to be the only vector that we can use for this specific requirement. I feel like there's plenty we can use. The thing of it is that how can we find one? Okay. I mean, if you... Now, usually people would probably be like, oh, if you have like X... I think it would just be funny. It's like, it's equal to 4. Then that's definitely not going to equal 10. I know that for sure. It's just going to be 9, and then 16. That's 25, and then basically we're left with 5. Yeah, it's the magnitude of 10 that makes it a little bit much more iffy to work with. So it basically has to be like B, so it basically has to have this relationship. I'm guessing that's what it is. And I think the answer to the question, I was right. It is no. Like, practically, it's not going to be the only vector that satisfies that. We just need an extra step to get the magnitude equal to 10. Yeah. I mean, for the magnitude to equal to 10, that might be the only thing that makes it unique. The thing of it is that how do we get it equal to 10? Because, I mean, there are, like, plenty of numbers we can use. Oh. No, wait. No. That would end up with 50. So... I don't think there's any number you can square to get 50 plus 50. Unfortunately. It's like, what's the square root of 50? Unless we can use all numbers. Because I'm thinking of just I'm just thinking of the whole numbers. But I guess we're probably going to have to deal with, like, the real numbers in this case. So if you had, like, then you would 25 times 2. Then you'll be left with 5 times 2. I mean, that would get you 10. Because, yeah, then you would have to multiply, like, 25 times 2 and blah, 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 blah. But let's keep the solution we had before. Yeah. Yeah, the only way this would work is if, yeah, if, like, by and bx were, like, equal to, like, I mean, that's the only way to get to 10, and I think that would probably be a unique solution. But I don't know if that's the only way you can get it to 10. But you have to just get it to 100 and then basically... But I think there are plenty of numbers you can do with that, though. Because let's see. If we have 64... Then we have to have 6... Yeah, like we have to have something with 6 in it. So let's see. Like 8 to the square. So 8. So... No, that doesn't work. Usually the mental arithmetic is the thing that I can't do. Wait. If you did 4 plus 36, then that would work. So that means that it's not a unique solution. There are other ways to get it. Okay. I have to actually brute force it, actually. That's the only way I can think of it. Because if we have 64 and then basically plus 36, then that would carry the 1 and that would give us 100, and then basically, yeah. Yeah, that's the thing with me. It's like when people have like a brilliant way of actually like just doing it without any extra effort, I end up doing the opposite. I end up doing like a hard way of thinking about it, but that's the only way I can think of like basically like a solution. Is just brute forcing it a lot, which I shouldn't do. I think it's because like I'm like when it came to problem solving, I always like basically ended up like doing it, and then suddenly like I would find something and I'd be like, oh, okay, we do this, and then I just solve the problem and I just forget about it because I'm like, okay, that problem's solved, now let's go to the next one. So I guess it's not a unique solution because there's plenty of ways to get to 10 in that case. As long as I found one, then basically I think that's how the question is answered. So I guess like the answer is, like the way we get it is this way. And then basically we would have to answer the question, which is it the only vector? And the answer is no. It's not the only vector that can lead you to the result. Okay, is there only 2 solutions? Why? Well, what do you mean 2 solutions? Are you just wondering why I wrote like, you know, like 64 plus 36? I don't think there's only 2 solutions. I'm just basically saying that because this question asks, is this the only vector that satisfies the specific requirement? And I think the answer is no, because I was able to think of 2 solutions to it. But then again, like, that's basically getting the magnitude of 10. There's only 2 vector of the norm 10 that are perpendicular to A. Like, how did you come up with that, Sascha? The reason is geometric. I can show you if you want. Yeah, you can basically post it in the stream material resources, and I can take a look at it. Let's copy this. Yeah, these problems are pretty difficult for me because I have to think like outside of what I'm used to. Because usually when it came to dot products and scalar products, I just basically keep quiet and calculate the thing. But now I actually have to think about them in a different way, which is probably good for me because that way it allows me to understand them a little bit deeper. Can I hop in Discord? Yeah, sure. Hey, Sascha.
Hello.
Okay.
What?
What did you wanted to show me?
I wanted to show you the geometric picture so it will help you understand the situation, okay?
Okay. So.
And use most. I don't know if that's okay.
Yeah, that's fine. Let me just open this up.
Okay, can you see my screen now?
Yep.
So what was the vector?
The vector is A is equal to 4I minus 3J.
Okay, so 4 minus 3, right?
Uh-huh.
So, okay, in Desmos it will show as a point, but I want you to imagine a nice vector going from the origin to the point, okay?
Okay.
Can you see the screen?
Yeah, I can see it.
Okay, here. So do you see the point in red?
Yes.
So maybe we can give it a little label. Let's maybe call it A. Okay.
Okay.
And I want you to think. Okay, maybe I will take a screenshot and draw the line. Okay.
Mm-hmm.
And so you had the linear system, right?
Uh-huh.
So what was it?
Let me open this up. So the linear system we have. Do you want me to read it as like just the pure dot product, such as 0 is equal to 4bx minus 3by, or do you want me to read it as 4bx is equal to 3by?
I think I will take the first one.
Okay.
But I mean, both are just like very similar. Just so you move the minus 3 at the other side, so you get this, right?
Okay.
Okay. And okay, maybe I will just take a screenshot of that.
Okay.
Sorry for the junkiness.
Sorry.
Maybe I will. Okay, that's a long line to do it straight. Sorry.
Sorry.
Can I have a rule something? I don't think so. All right. Okay. You will have to excuse my very not straight arrow.
It's alright.
Okay, so what can you say about the blue line compared to the vector A?
The blue line is, well, it is perpendicular to it.
Yeah. So you see any points on the blue line would be a perpendicular vector to the red one, right?
Right.
Okay. So there are two things I wanted to show you. So first of all, I want to explain you why there can only be two vectors that will satisfy the condition that the norm is 10. Okay.
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 And for that, maybe I will just swap. I will just swap the grid in Desmos. I don't know if you know that, but in Desmos you can swap from Cartesian to polar.
Okay.
And it will, so polar coordinates are basically the norm, right?
Yeah.
So a point of example in the circle with the 4 here, like all the point lying on this circle have norm 4, right?
Uh-huh.
So if we zoom out a little bit until we reach 10, then all vector of norm 10s are on the circle with the other circle with the 10 here, right?
Okay.
And here you can see the two solutions. So what are the vector which are perpendicular to A, which have norm 10?
Uh-huh. So it's, oh, okay. So like 10 is considered like a circle in this case. And where the line hits is basically twice.
Yeah. So you get 2 points. Yeah, exactly. That's pretty good.
Okay.
So those are the two solutions you.
So why did you have to change the polar coordinates for that to happen though?
Because I just wanted to show the norm. So when I went into a polar coordinate, now the axis the axis just give me the norm, so it's easier to see. But It's more just for convenience.
Oh, okay.
So those are the two solutions you would have.
Okay, I understand that makes sense for the Cartesian. I mean, for the polar coordinates.
But we don't need polar. Polar just show us the vector of norm 10. Like it does not do anything. Like the point I had before was still be the two vector of.
Yeah, and I see the line basically passes through like -10 and 10.
Yeah. So maybe if I want to write in the polar coordinate, what I could in the Cartesian coordinate, what I could have done something like that, right? The two solutions at this point and this point, right?
Okay.
And okay, so also what I wanted to show you is that so you were really able to find the solution. So you were able to find a perpendicular vector, right? Like you did it like a king. You just find a solution to that, right?
Yeah.
Of course, there's many solutions because I mean, if we look just at the picture, we don't get a single point. We get a whole line, right?
Yeah.
And you find a vector 3, 4, right? Which is fine. Like you can see in the picture, it's on the line, right?
Yeah.
But then after that, you sort of kind of discard it because it doesn't have the right norm, right?
Yeah.
So what you found is this guy has norm 5. Maybe I can pull back the Cartesian plane to show you that, but the Cartesian, but the polar plane. And the thing which is cool about it is is that okay? So if I take, for example, a point which is at 10 here, okay? What do I have to do to this point to get this point here? I don't know if you see it.
Yeah, like the point you just clicked on, right?
Yeah.
Like what about that point?
So how could so the point in purple, which I will call it, I don't know, C.
Yeah.
As norm 5. I think that's the thing you computed. I mean, we see clearly in this graphic it has norm 5, right?
Yeah.
So if we want to change our vector to have norm 10, because that's the thing we care about it, we can do a simple modification to this vector.
Okay.
So so this guy has norm 5. Okay, so maybe this is a thing that you maybe don't know about it, but if you have a vector, I don't know if I can draw on something. Maybe I can draw it on the snippet tool. Okay, if you have, for example, a vector, let's call it V. That's a good name for a vector.
Okay.
Okay, and let's say it has norm 5. Okay.
Okay.
So if I decide to scale this vector by a factor of 2, so I multiply every component by 2. What will be this norm of this guy?
That would be 10.
That would be 10. So here what you could have done with the solution you found is said, okay, this guy is norm 5, but I want norm 10. So if I want norm 10, I can just multiply both coordinates by 2, and then I get exactly the vector I wanted.
Oh, okay.
So so that's basically the condition of having a norm seems a bit overwhelming at first, but really if you're able to find a perpendicular vector, then it's really easy because you can just multiply by constant to get the desired norm that you want. Okay. For example, you will usually people see. I mean, one thing we sometimes do in physics or in maths is, for example, if we have a vector, I don't know, we can give me some garbage coordinate like 11, 13, something like that. And they want a vector that point in the same direction, but they want the norm to be 1.
Okay.
So what people do, they just take this vector and they divide by the norm.
Okay.
So that would, okay, maybe I should remove those lines.
Which is a unit vector.
Yeah, and if you compare it to the original vector, okay, maybe 11, 13 was maybe a bit too big.
Yeah.
Like you can see they're on the same line. It's just like the red one is a scale version of the original. So the norm is not really a condition you should be very afraid of, because whenever you have a vector, you can always like divide or multiply by some constant to get the desired length that you want.
Oh, okay.
Okay, I don't know if that tells you a little bit.
No. Like it's like I'm aware of the relationship, like with I guess like for me, I'm just so used to seeing it as the definition of a unit vector. I just never thought of it manipulating it in that way. Like I think that's the reason why like I don't usually think about it that much. Because for me it's like I know the definition, and I know like I guess like if you were to tell me like force is equal to like m F equals ma, right? I wouldn't think of like the clever ways of manipulating like, oh, I can turn like a into like, you know, vi plus t of a or something like that, or something like around that. Or no, like I mean v equal v times t. I wouldn't think of like something like that, you know?
Yeah. And the other trick I wanted to show you is that actually this idea is generalized to 3 dimension as well. Okay.
Okay.
So if you go to 2D to 3D, there's no like you shouldn't be afraid. Okay.
Okay.
Like if you have a plane, not a plane but a vector. Let's say I don't know, but maybe let's give it those coordinates. Okay.
Okay.
I can imagine there is an arrow that's pointing from the origin to the red point here. Okay.
All right.
I don't know if we can do arrow in decimals, but I guess we're gonna use a little bit of our imagination, okay?
Okay.
And you can do exactly the same trick, so you can write the system of linear equation, right? So if you use the dot product, what's gonna be the system that you're gonna get is you're gonna get, maybe I will just put some other coefficient, maybe 1, 2, 3. The linear system you will get will be 1 times x plus 2 times y plus 3 times z, right? Equals 0. That's the condition to be perpendicular. And when you do that in higher dimension, for example in 3D, you no longer get a line. You get an entire plane. So all the points you see all the vector you see in the blue planes are now perpendicular to the vector represented by the red point. Okay. Maybe you've seen that in geometry. What we could say is that the vector in red is normal to the plane. Okay. And now if you think about it, so maybe let's ask the same question: how many vector of magnitude 10 are perpendicular to the red vector? What would you think would be the solution?
Like what vectors are perpendicular to it? Is that what you're asking?
Yeah, but of norm 10. Like how many of them are we gonna get? Are we gonna get like 1, 2, or more? I don't know.
I'm thinking, well, we got 2 for the last one, and that was a line. But this one is a plane, so for some reason, I keep thinking it's gonna be 3.
It's gonna be a bit more than that. So
right? Yeah, because it's an expanded space.
Yeah. So the condition here is that so if we want a vector of num 10, what we're gonna do is we're gonna look at when so vector of num 10s are given. Okay, maybe maybe we will not put 10 because I don't think the program uses it. So maybe let's say norm 1. Okay.
Okay.
But it's probably doesn't change anything. So it will be given by the intersection. So okay. So the green sphere here.
Yeah.
Do you agree with me that the green sphere? So maybe we can just remove everything. Is all the vector of norm 1, right?
Okay. Yeah.
So this we agree, right?
So if we want to find the vector which are perpendicular and of norm 1, what we do is we look at the intersection of the plane and the sphere.
Okay.
And okay, here maybe it's a little bit hard to see, but I don't know if you can imagine it. So, what do you think you will get from that?
Practically anything around that radius.
Yeah. So it will be a whole circle, right?
Yeah.
Yeah.
Okay.
So in general, so if we go even in higher dimension, in general, if, for example, if you ask the norm to be 1, so if you have a vector, maybe I will write it in text because otherwise I will just yap a lot.
Uh-huh.
Usually, if you have a vector A,
Uh-huh.
and you want to find all the vector B which are perpendicular to A, and let's say B as a fixed norm, so we can put 1. I mean, it doesn't really matter. I mean, that will just change the size of the sphere, but not really the amount.
Uh-huh.
So B is equal to 1.
Uh-huh.
So what you will get is you will get a sphere
Okay.
of the various dimensions. So this will always be a sphere.
Oh, okay.
And in the case of the 2 dimension, it's a little bit weird.
Uh-huh.
Because the perpendicular vector are on a line, right?
Yeah.
So we'll get, so the sphere we get, we actually get a sphere, but the problem is the sphere in 1 dimension. So, so if you have a line, right?
Mm-hmm.
Like that. And so the definition of sphere is always the same. It's just all the points of distance 1, or whatever what the distance you want. Here we want the distance to be 1. Okay. But the problem is on the line there's only 2 points. It's kind of a very weird sphere, right?
Okay.
Like if you imagine the real line, you will get 1 and -1 are the 2 points with norm 1 from the origin, right?
Uh-huh.
And so that's a kind of a very special case where the sphere is only like 2 points, and usually you will get an infinite number of solution. But in the specific case of 2 dimension, that's not the case because the perpendicular line is 1 dimension. Thus so thus we get 2 solutions. That's kind of a weird case.
Okay.
Okay. I don't know if that helped a little bit.
So what were you trying to show us with this second example that you were presenting?
So you mean in the 3D Desmos here?
No. The red line with the -1 and -1. Like.
I was just showing you that we still get a sphere, but it's just the sphere is like in 1 dimension, and the sphere in y dimensions are just 2 points. So it's a bit of a weird sphere.
Oh, okay.
Yeah.
Oh, okay.
That was just what I was trying to. Yeah.
Is that wouldn't that be considered like an interval if it's like just 1 dimension at that point?
Yeah.
I see. Okay. Okay, like that's like way different than I was thinking about. Interesting. I never thought of norms like this way, but then when I think about the mathematical way of writing it, like it is like the square, like it is a distance formula, and when I think about it, it's like, you know, if it's like a radius, then it makes a lot of sense.
Yeah. So when you think about perpendicular, you have to imagine like you have a line which is perpendicular to your vector. If you're in 2 dimension, if you're in 3 dimensions, it's going to be a full plane. But yeah.
Oh, okay.
And the norm is not really a condition that should bother you. I mean, in quantum mechanics, they sometimes have the wave function.
Yeah.
But so you're supposed to, when you take the norm of that and you integrate the wave function, you're supposed to get 1 because it's supposed to open the probability, right? But sometimes in your problem, when you're not very careful, sometimes you will sometimes your wave function will not have norm 1. Okay. And so what people do, they just divide by some constant to make it now of norm 1. So.
Okay.
So changing the size of a vector is a very easy operation. You just have to multiply it by some constant, and then you get what you want.
Yeah, I think it's because like since I'm working on like a physics problem, I like all the math that I know, since it's not considered like math, like I guess like the subject math, like my math brain is like not making the connections there. I think that's the reason, because like I'm thinking like, oh, I'm in a physics class and I have to think the way the physics professor wants to me to think. But then, like, at the same time, I'm like, oh wait, like, it also involves math. So I think, like, for me, it's like I have to get my math knowledge, but at the same time, it's like I'm not being piggyback into basically saying, oh, this math operation is going to solve 100% of the problems here, or this math technique.
So this was a theory, but actually when you want to do computation, you can go faster than what I did here. So here was more like showing you pictures, so maybe hopefully the picture will help you remember a little bit about why you only get two vector of norm 10 and at least a way of thinking about perpendicularity in general. I mean, at least that's my hope. But when you do computation in the plane, you can really you can do things very fast because there are some algebraic tricks that usually people learn. So so what was it? We have 3 and minus 4, okay? Okay, maybe I will put it as a vector.
Are you trying to use the same vector we had before?
Yeah, I mean we can use it basically any vector it would work, but
I think it's 4 and then minus 3. So I think it's reverse.
Yeah. Okay. If I want really to do the magician trick, I guess I should ask you to choose the vector. So you can so maybe you cannot say, oh, we used that one already, so you already knew the solution, so you're cheating. So can you make up a vector for me?
Okay, so how about like 2 minus 5?
Okay, so you want 2i minus 5g, right?
Yeah, minus 5j, yeah.
Okay, so that would be a vector A. Let's call it like that. If I want to find a vector which is perpendicular to A, there is a very simple trick to do in 2 dimensions, which is we're gonna flip the coordinate and we're gonna add a minus at somewhere.
Okay.
Okay.
All right.
So maybe I will swap the coordinate and I will put the minus on the first coordinate. Okay.
Okay.
So we'll get 5i, sorry, minus 2 plus 2, sorry, plus 2j. Okay.
Okay.
And now I want you. I guess we're kind of doing a magic show. So I want you to verify that when I do a dot b, I get 0, right?
Yeah, and I think it's pretty obvious that you will end up with that.
Yeah. So that's already a thing that you can do. So in general, if you have that works in 2 dimensions. If you have a vector given by ai plus bj, if you want some perpendicular vector, what you can do is you can put bi minus aj. And this will also work.
It's like something that's obvious, but when I think like if I have a problem that kind of like, I guess it's not obvious to use that type of trick, I would probably not think of it. I would probably not think of it. Yeah.
Yeah, I mean, it's a very silly thing that happened in 2 dimensions that it turns out you can just swap the coordinate and put the minus somewhere, and then you get something which is perpendicular. And here you can sort of see the 2 solutions because I have a choice of putting the minus on the second coordinate or in the first coordinate. They both work. Yeah, so you get the 2 vectors.
Yeah.
Like that.
But you can only do that in 2 dimensions. I mean, like.
Yeah, in 3 dimensions, it's more annoying.
Yeah, it seems more annoying. I see that. Anything else you would like to teach us / explain to me?
Well, I guess we have 5 minutes, so I guess I will do my shout out to MathSpellBook, and I will encourage people to subscribe, follow, drop the bell, and the usual stuff.
I feel like the whole entire time you've just been like watching me just struggle and kind of like grumble about how I'm failing these problems. No.
I don't know. I think in the last time you had like some very good grip, but okay. First of all, I'm convinced that you're able to find perpendicular vector. Like, I mean, you showed me you're able to solve a linear equation, so I mean, you're more than capable of that. But you kind of like have some kind of mental breakdown because you had the norm, right? Which is what's bothering you, right?
I think what was bothering me with the last one was that, I think it was the norm. Like basically just trying to find like the right norm, but then I kind of brute forced it because I was like, okay, I can find out which numbers give the norm, but then I have to remember, oh wait, it has to be like equal to 0 for the other things.
Yeah. Yeah, you could also have tried to solve the system with so your second item was, and not your first item, I don't remember which one, but at some point you had like 2 equations written on the screen.
Oh, I think I did that because like you typed something about like do it, and I was like, oh okay, maybe I should try like 10 is equal to like bx plus by, and then because like in my brain I was thinking that, oh, this kind of looks like a linear algebra type of problem in my brain, but it was just funny, but I was just like joking. And I think when I basically said it'd be funny if I wrote like 10 minus like, you know, bx plus by just to see what happens, and then I saw in the chat you typed like do it, and I just decided just to do it just for fun, just to solve like a system of linear equations, but that had nothing to do with the problem whatsoever.
But we could have done this route, so obviously we wouldn't have ended up with a linear system. But so sorry, I always forget. What was the vector again? It was
it's 4
-4.
It's 4i, not minus 4. It's just
plus.
Positive. It's plus, yeah.
Oh yeah, it's okay. So
and then -3. Yeah, -3.
Okay, so you had like for first system you have. Okay, maybe I would put some x, so for 4x minus 3y is equal to 0. I mean, I think you had the equality on the other side, but I mean, it doesn't matter.
Yeah, because it's supposed to be the dot product between like a and b.
Yeah, and the condition that the vector has norm 10 is x squared plus y squared is equal to 10.
Yeah.
So here the linear algebra fails because the second equation is not linear, but we can still do an algebra on it.
Yeah, okay.
So if we use first equation, we will end up with 3y is equal to 4x, and we can change y to be equal to 4 over 3x, right?
Yeah.
And now we can use this substitution inside of the second equation.
Okay.
So we end up with x squared plus 4 3 x squared is equal to 10. I mean, we would end up with x squared plus 16 over 9
x squared, yeah.
10. And then here we're gonna have 25, I think. 25 over 9 x squared equal to 10. And now we could have just throw this guy on the right and isolated x, and from that we can figure out the value of y. I mean, I think you know how to do after that.
Yeah.
So we could have done that. This will have work also.
Oh, okay.
But at least I don't know if you agree, but I think the easier solution was just to ignore the condition of the norm. Just find some perpendicular vector and then multiply by 2 to get, multiply by some constant to get the norm equal to 10.
Mm-hmm.
It's probably less work.
Mm-hmm.
Yeah.
I see. Okay. Well, thank you for taking the time to explain all that and for the visuals, Sascha. I always appreciate it.
Yeah, I think the visuals help to understand. So hopefully you will remember the picture.
Yeah, I think it's basically the clever tricks as well as the visuals I'm lacking when it comes to like problems, I think.
Yeah, I mean, there's like some trick, like for example, swapping the column and putting a minus. There's like no reason to believe that this should work, but it actually works in 2 dimensions. So
yeah. I think it's also
you get to see it once to know it.
Yeah, and I think it's also because I know like all you guys in chat are like very, very smart, and sometimes you see things.
Nah, you're smart too, okay?
So for me, it's like I feel like I'm doing it for like a committee of mathematicians, and it's like this is the time to prove myself, but I don't end up doing it, and it's like, oh wait, I missed something, or I missed this one step, or I missed this negative sign. So sometimes I get intimidated, and like, you know, sometimes that's when my ego gets in the way when it comes to that stuff.
I mean, the problem you did today was, I mean, okay, you were not able to finish all of them.
Yeah.
But I feel you had like some kind of originality, like you had some idea and you kind of stick with the idea, and I mean,
in the two problem, you were like kind of like millimeter away from having actually a full answer.
Yeah.
Like you were really, really, really close.
Yeah.
And I kind of really like for the first problem, you kind of went like not half road, but you had an idea. I think it's pretty good because you had an idea which is a little bit different from what maybe the book would suggest you to do.
Yeah.
But you still like held your ground pretty well. Like you were able to reason about it, and you were able to to work with it. So I think you did somewhat good because. Okay. So sometimes you can get like the answer, like you can get the right answer, but maybe like you just like copy some previous example, right?
Right.
So what is worth having the right answer but having copied the example? I mean I don't say it's bad, but I mean.
No, yeah. I think you're basically saying that you like the approach I'm taking because it's sort of like I'm just using my own brain to like navigate to the solution.
Yeah. I really like the first one. Like you really, I really liked it. What was it? Was like norm of A plus B is equal to norm of A minus B. Therefore, A is perpendicular to B. I think that was the question you were doing, and you really went in your own way, which is very good, I think.
Yeah, I think like for me, it's like if I know if the book gives a definition, I try to basically like see how that definition goes. And hello, silly monkey, welcome to the MathSpellBook chat. Basically, I usually like guys, you will probably see me get stuck more often. Like I will get stuck more often because like either a definition doesn't fit or I realize that I'm in a road where it's more complicated than I need it to be. And I think that's the time when I feel defeated because it's like, oh wait, now I have to look at the actual solution because usually like I'm not at a point where I can do problems and there's no solution. so like I'm not that like skilled yet. So like for me, I keep doing problems that actually have solutions, but I know eventually like if I keep going at this route, I will eventually run into a problem that I don't have a solution for, and then I have to think about what is it that I need to do that's right. And I think sometimes when I do these problems, like for you guys, I feel as if, wow, I am so not ready to do like, I guess, graduate level type of like questions. Because I'm still thinking like, what would the textbook say in this case? Like, I mean, I'm kind of glad that you actually said the positive stuff that I was doing, Sascha. I really needed that, actually. Because I think, like, a lot of people that probably watch the videos on YouTube or whether watch the live streams, they feel discouraged because they feel like their thinking is not the way you should be thinking about it, because that's how I'm still used to thinking. And then when I look at a solution in a textbook or on a website, I'm like, wow, why didn't I think of this? And I try to think think of it, the solution, the way they do it. And I'm like, what is the other way I can think of this solution that's originally myself, but I never asked this question? And I'm pretty sure that a lot of people that are in school, they fall into that trap.
Yeah. I mean, you have to think like, okay, when you leak, like, for example, the solution book or like some answers online, you have to think that those are a little bit like Instagram, you know, like, you will see picture of like people having like perfect life and perfect physics, but I mean that's not reality. And in my real, like, kind of, okay, this proof have been known for like 200 years, so like people kind of optimize it like to be very short and to be very elegant, right?
Yeah.
But obviously the first guy we came out with that in fucking 1900 was like, I mean, probably the proof was like horrible, you know?
Yeah.
So it's completely fine when you write the proof and it's like not very appealing or something. Because,
so like, say like if you had like someone who had an original idea and they made a proof about it, and they basically have a really legit proof, but it's not it's not very clear to everyone at first.
Yeah. I mean, in research it happens all the time. You have like the original paper, which is unreadable sometimes, and then you get like two or three people try to make it more readable, and like, oh, people finally get it.
And then they know the techniques and they reduce it more, and they're like, oh my god, this proof is elegant. And then like the first person that actually came up with the solution, they're like, wow, I didn't think of this. Like, it's impressive that you thought of this simplification. I was like, beating my head with this. And it didn't look as elegant.
unfortunately, I'm teaching you a real analysis, which is like the worst offender of that because I mean, is go back to 1700 and people like kind of very optimize the proof, so everything is kind of a very elegant and very short proof. But if you look back at what people were doing originally, they were kind of banging their head against the sheet of paper.
Yeah. Let's see.
Something else.
What'd you type, silly monkey? I'm just like, I'm cooked with oh, is that with to be honest, is this, oh, okay.
So it's more important for you to think like on yourself than having like the perfect fitting proof in the solution. What's that? Because
well, yeah, like if you guys come to the watch the videos on YouTube or come to the streams to see me mess up, you're in for a show. I mess up all the time, and like if that gives you more humility or whatever, and I still love the subjects, don't get me wrong. In fact, like I think when I do physics problems, I feel like I'm interacting with the math more, because like since it's not generally a math course type of way of thinking, I have to think about it in more physical and more real, like more like a scientific way of thinking. But I also have to find a way to build the math so it makes sense for the science to work. And I don't know if you guys like it when I do physics problems more, or you guys like it when I do math proofs more. So, because the only reason why I'm doing math proofs is to basically develop, like, I guess the more abstract mathematical mind, so it could be more applied to, like, I guess physical phenomenon in that way.
Yeah, thinking of proof was so very ugly at the first. One of the things I worked during my master, the original proof was completely wrong. It was not just ugly; it was completely wrong. But not completely. But I mean, the core, one of the core argument was wrong. So you kind of make it into an incomplete proof.
Oh no! Like when I look at your questions, like for like what you want me to learn, I look at like the proof questions and I'm like, oh wait, I have to remember this. I have to remember this relation.
Oh, yeah.
And then I have to think about, oh, how did you set it up again? Because like for me, it's like I have to remember how you set it up, but then I'm like, wait, how do I define this? What does this definition entail? Like, all these different details come at my head and I get so overwhelmed. And and it's like, okay, what is the right way to think about this? And I think that's what people struggle with the most, is like, how do they organize their thoughts so they can actually like get to a proper solution that is like gonna make sense to them.
Yeah.
And that is correct, yeah.
Yeah. I mean, usually when you read like the new definition in mathematics, you've probably like read it 20 times. You're like, I don't get it.
Yeah, because
that's usually all the process.
Sometimes when you help me in chat, I'm like, okay, like you're seeing it in this way. So I think for me, my brain goes into like, okay, how am I gonna see it the way Sascha sees it? And sometimes that kind of like overwhelms me, because I'm like, okay, wait, now I'm not thinking about the way that I started. Like I'm not thinking like how I started, and then I lose track of how I thought, because I'm trying to see how you think. And like that's the thing where I'm like, I get a little flustered, because I'm like, wait, if you see it this way, then why can't I see it this way? But then I lose track of what I'm actually supposed to see from my point of view. And I think when it comes to that, the struggle is like, okay, I gotta make sure that I maintain what I'm thinking in my own head originally, but I also have to like take in some input from what you're saying, but not let it overwhelm me to the point where it's like I forgot everything that I just learned about from what I started with.
Yeah, so I mean, that's kind of the thing. Like usually when you read a definition the first time, like I don't usually get the definition.
Yeah.
But then I read it and then I think that usually I'm very stubborn, so I will probably like trying to use it and figure out like how to prove the theorem or something. But then I will get nowhere because I don't get the solution. And then I will do like the dishes, and then I was like, oh my god, why am I so dumb?
No, I think that happens to everybody. It's like when you're stuck on a problem, you basically think, how can I solve this? But then when you take your mind off the problem for like at least a couple minutes, you realize, oh wait, I didn't do this type of approach. And then you start doing it.
Also, I don't know, maybe that could be a cool thing that you could do on stream, but and I think it will help you. So what you could do is try to summarize what we learn on stream.
like, I mean, I don't know what you were talking about. Maybe we were talking about Cauchy sequence, so maybe you can try to, from memory, try to remember what is the definition of a Cauchy sequence and what's like is the big idea. Like trying like to explain like to someone who is completely new. Do you know what I mean?
So like basically summarize everything that we've learned on stream, right?
Yeah, because when you're kind of teaching that to someone else, I mean, in a perfect situation, you would be teaching to someone else, but I mean, I don't think we can find someone who is new, and usually it's kind of interesting because usually you have like your own conception of like some notion. For example, maybe you have an idea what is a Cauchy sequence.
Yeah.
But then when you try to explain it, everything like came out wrong. Like you say the thing, and then like you realize, oh, I have hole in my understanding of the subject, which I didn't realize. So it helped to explain stuff to other people. I think that's really.
I think that's why I think I started the channel because of that. Because like once I learn something new, I try to like summarize. Because like every problem that I get wrong, if I see like a solution, then I basically explain the solution in a way that I understand it. And you know, like if you guys are watching this on YouTube, probably it's like the way you would probably see it too. And like, you know, maybe that will help you in your understanding of the problems. So yeah.
Yeah. And usually that's what I do. Usually, like when I'm stuck on a problem, I need to talk with my advisor. I told him, I first of all start with the, if you want the story time. I explain what is the problem, what is the, what I try and what I think about what approach should work. And like when I do that, I mean, most of the time I realize that some of my idea were I had flaws, stuff like that.
That makes sense.
So it really helped to teach or at least talk it to someone else about like your train of thought.
Yeah, I think for like me, like I have to constantly like remember that my goal is to basically learn complex math so I can actually learn more complex subjects with physics. So that's why like I keep switching like back and forth. Like it's not like that I don't like proofwriting, it's just that for me it's like the only reason why I'm learning proofwriting is just to learn the abstract ideas within math. So that I can implement that. At the same time, it's like I haven't picked up a book on like mathematical physics yet. And like I started reading a little bit of the book that you recommended. I think it was the book by Vladimir, I think. And I loved the first chapter, like how it started, because it brought some subjects about linear algebra and all that stuff. So I think like when it comes to like my goals, I end up asking myself this one thing. It's like even though I like proofs, for me it's like proof writing, I feel as if it's kind of like something that I don't mind doing, but at the same time it's like something that I feel as if it's like kind of like deterring me from like where I'm trying to get at. You know what I'm saying? So for me, it's like I'm more inclined to learn more about math techniques so I can actually implement them for like physics. Like that's how I think my mind is working right now. So I think for proofwriting, it's sort of like something that I can pick up, but it's sort of like, I guess like the thing I can put on the side to basically like learn more math techniques to get into physics. You get what I'm saying?
Yeah.
Like, I mean, I'm really impressed that you basically showed us like where the negative numbers come from and all that stuff, and I want to continue on with like learning about the proofs involved with the real numbers so we can get into linear algebra.
Yeah.
So, you know, but like since you are my teacher, I will leave you to decide when you think I'm ready to like learn that material.
I mean, okay, actually, it's been a while since I've looked at what I give you as an exercise, so maybe...
The last thing we stopped at, I think we were learning... Let me check here. I have it on my files.
What was sheet on...
Last one we did was, I titled the video, The Real Numbers Are a Field. And I think that's the last thing we stopped at. And I think...
I mean...
Uh-huh.
I mean, I remember what I did, but I don't remember what question I asked you to in the exercise. It was the thing I was wondering about.
The only thing I remember is what you were going to say next time. Like, what you were planning to teach about next time, which is, like, finishing the real numbers. and then going into linear algebra.
But
yeah.
I was thinking about the sheet 2 I give you. What the problem I put on the sheet, like what?
Let me take a look because I only have two sheets.
So question why I ask you to show that Q is a field. I mean that's kind of an annoying question because it can be a very complicated answer or
because like
one.
I think the last exercise on the sheet you put in is exercise 6 or no exercise 5B, and that's basically if P is a function from Q to Q is a polynomial function. I think you're basically trying to.
It's a polynomial.
Yeah, Px is a summation of like from K to 0, from K to M, Bn. So I'm thinking like it's a Cauchy sequence question.
Yeah. So for sheet 2, I would like you to focus on exercise 3 and forward.
Exercise 3 for the second sheet?
Yeah, for the second sheet, I want you to do exercise 3 to 5. I mean, the first two are kind of, sort of relevant, but not really.
Yeah, this one's like metric spaces.
Yeah, exercise 3 is probably more, exercise 3 is an important one.
Because it involves like sequences.
Yeah, so you will learn how to manipulate convergence and stuff like that. So, which is like kind of the ball of the warp, and not the ball of the warp, what's the expression in English? It's kind of like the pain of real analysis 1 is to be able to manipulate the epsilon delta definition.
Okay.
Like if you master it, you basically master analysis 1, so exercise 3 is kind of an intro to that, so it will be like your first encounter with it.
Let's see, exercise 4 is that show that if an is bounded sequence in the rational numbers, then B is, an over n plus 1
goes to 0.
Goes to 0. Okay.
Like those are, yeah.
So
exercise
like
5 may be a bit more involving, but
exercise 3 and 4, yeah. And 5, right? Okay.
Yeah. If you get stuck, we can do some of them also together. But I would like you to first try.
Yeah. Okay.
For example, exercise 3, C and D are not that easy.
C and D? Oh, okay.
Yeah, exercise 5 is not easy, no. Also, but exercise 4 is a bit more.
Okay, I see.
All right.
Like if I get stuck and like I'm not able to contact you, would like me putting this in ChatGPT, would it give me the correct answer, or would it basically be like give me like a nonsensical answer?
I guess probably, because I think those are kind of like those questions are kind of in every analysis 1 book, so
it's standard, right? So like
it's
more
pretty
likely...
standard though.
Okay, gotcha. All right, maybe I'll give them a try, like maybe tonight. See how it works out. Okay, guys, we chatted a lot about our experiences with the struggles of math and physics, so hopefully you guys enjoyed that. I will be posting this on YouTube, and thank you, Sascha, for joining us and basically sharing some of your knowledge as always.
Yeah.
All right.
No problem, friend.
Yeah. So I will see you later, Sascha. Thank you again.
See ya.
Okay. All right, guys. Let me just move this out here. Right here. So we did basically like just a couple problems, and I have to personally thank Sascha for basically encouraging me through the struggle. Because like, it's like I said, like sometimes when you don't get to a solution and then you realize that the solution was kind of a little bit of a simpler concept when you look at like a solution that was created by like someone else, and you start kind of being hard on yourself and like get a little bit of a mental breakdown. I think what Sascha reminded me is like, you have your own approach to trying to get the answer, and like just because your approach was wrong doesn't mean that makes you any less of a person. And sometimes like I forget that. So hopefully hopefully this message will get through to you guys if you're watching the videos. But thank you for joining me today, guys. I will join up with you guys tomorrow. So if you guys want to check out my YouTube channel, and for those who are on Twitch, you can check out my YouTube channel. That way, if you miss any of the live streams, you can basically catch them back there, because I do record them while I'm streaming as well. So that way we don't face any major issues. In addition, I will also be about our Discord server. So if you like math and physics and you would like to just nerd out with us, there you can basically join our Discord server. And in addition, you can also follow my gaming channel, my Uncle Talks channel, where I play video games and I just talk to you guys about stuff other than math and physics. So, and if you're watching this on YouTube, all the links will be in the description down below for like my Twitch channel, as well as the Discord, as well as my Uncle Talks Twitch channel as well. Okay guys, thank you for joining me today. It's always been a pleasure going through the struggles of studying math and physics for a greater purpose for myself. So thank you for joining me on the journey today, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream tomorrow. So take care guys. Bye-bye.